Good afternoon, everyone, and welcome to today's APM webinar, Bringing Brent Home, the story of Brent Decommissioning Project so far. I'm delighted that William Lindsay from Shell UK Limited is joining us. I'm Robert Allen, APM Branches Manager, and I'll be your host today. It's great to see so many people have joined us, and I hope this finds you well. We're certainly keen for your interaction today, so feel free to submit your questions via your control panel, and time dependent, I'll propose these to William at the end of the session. Today's session will count towards your CPD and should last no longer than an hour. I would personally like to say thank you to the APM East of England branch for all their achievements in making today's webinar happen. And on that note, I'd like to pass over to Daniel, one of the committee members from the branch.
Thanks very much, Rob. Good afternoon all. My name is Daniel Bradley and I am a committee member for the APM East of England branch. I'm delighted to welcome you all to the first and also the last branch webinar of the year. We are on the lookout for speakers for 2021, so if you're interested in being a speaker or you have any topics that you think would make a great webinar, then please reach out to me via LinkedIn. Today, our guest speaker is William Lindsay, as mentioned by Rob. William is a project director for Shell UK. He holds the registered project practitioner qualification with the APM, and he'll be given an overview of the Brent Decom project. So over to you, William.
Thanks very much, gents, and thank you for giving me the opportunity to go through some of the story of Brent Decommissioning. I'm going to start with a disclaimer, which you don't really have to read in entirety. There won't be a test on this, but all this does basically is to say that anything I say I won't be able to influence the share price of our current company. So when I was asked to explain a little bit about what's happening in decommissioning, I wanted to give an impression initially about what decommissioning is, and then focus on Brent in itself. So Brent is a large field in the north of the North Sea, but the project delivery element of the decommissioning of Brent is not too dissimilar like any large complex project. There are technical challenges, there is cost and schedule focus, and there's a lot of external interface as well. It's been going on since 2008, and there has been a lot going on, a lot of lessons in this evolving part of our oil and gas industry, and I hope in the course of the next 45 minutes to show some of what we've been doing over the last few years. So first of all, what is decommissioning? Well, decommissioning is like the final chapter of the life cycle of an oil and gas development. So if we do start at the first ability the need is to find oil and gas for economic purposes. And first of all, you have to find it. Once you find something, then you have to design and build a facility. That takes a number of years, and then you move into the operations phase, which can be, in some cases, a few years, and in other cases, it can be decades in the case of Brent. And over the course of the operations phase, then we might upgrade it, we might support it, and then we might look at methods for expanding or enhancing oil or gas production as technology has changed. And then we move into what's called the end of field life phase. And the end of field life phase is a very important phase because then we have to make a decision on when we're going to stop production, or COP, cessation of production, as we call it in the industry. And then the plan for the decommissioning phase. And after decommissioning in its various guises, which I'll explain later, we also have to have a monitoring phase for a number of years after that. Depending on the size of the impact, defines what that monitoring will be over a large period of time. So this the key element of decommissioning is actually to think about it early and to plan for it. And it's the same as any project that we do. If we rush into a project without good planning, you generally get undesirable outcomes. And so the focus is a lot on that planning phase and planning early before COP. And typically the objective of decommissioning is to do it safely and efficiently, but also the underlying principles of doing it environmentally responsibly and also to protect reputation. So what's the size of decommissioning globally? You know, it's 80–90 billion dollars will be spent globally over the next 10 years. 40% of that will be in the North Sea, and the biggest chunk of that will be in the UK sector as well. We are blessed in this particular part of the industry with an industry group called Oil and Gas UK, who once a year taking data from an annual survey provided by all of the operators. They take that data and then they generate an insights, a future insights report, and it comes out annually every November. And if you're in the industry, it is essential read because it gives very good clarity on what the type of projects is going on, and then the size of future workload as well. And interestingly, a couple of things is that we actually decommission more wells than we drill these days in the UK sector. But the actual activity, the cost of that activity is still only about the 10th of our total cost of operating our oil and gas facilities in the UK. It is a growing business. It's about £1 billion per year business. It is growing slightly, although with the cash constraints that many companies have been finding this year, there is a general trend that we don't spend as much in decommissioning as we had planned 2 or 3 years ago in our plans. So the biggest part of decommissioning project, particularly offshore, is the wells. So that decommissioning a well is what we call plug and abandon, which is essentially ensuring that the wells, which are vertical conduits for transporting oil and gas from subsurface reservoirs to the surface, decommissioning those wells is a way of isolating the reservoir so that those hydrocarbons never reach the surface again. Because even if a field is not economically relevant for production, there still can be residual elements of hydrocarbons which we need to ensure stays in the ground. So decommissioning happens all throughout the North Sea. Most of it at the moment is being spent in the North Sea and the central North Sea, with the southern and Irish Sea coming up as well. And that's primarily to do with the age of the infrastructure that we have around. So decommissioning is bounded considerably by a regulatory environment. The regulatory environment is new compared to a lot of regulatory environments, say onshore, and established over a number of years. So it was agreed to tighten up the regulatory process for decommissioning very much after Brent Spar, and what that requires every organisation to do is to consult with stakeholders on how they're going to comply with the requirements of decommissioning, and they do that via a decommissioning plan which is issued in the public domain and consulted thereof. There is an increasing cost focus on decommissioning because there is, and it depends on the field and how long the field's been there, but there is an element of tax relief on decommissioning costs in the UK sector of around 60%. So it's very important for Treasury to understand what the decommissioning liability is. Indeed, it's very important for all organisations to know what their decommissioning liability is. So it is a very relevant part of any operator's business. And then in order to balance activity versus the risks to the environment, then we have to perform these comparative assessments. And those comparative assessments, there's a structure on how to do that based on competing elements between safety, environment, societal impacts, the technical doability, and then the economic comparison between the options. And the OSPAR was created in order for all of the countries who bound the North Sea to come together to have a consistent approach to how we do decommission. And it's based on the principle of no dumping at sea. So if you put something there, then you get rid of it at the end. But there are possibilities within that agreed framework to leave certain facilities in place. And that is largely around cuttings. So cuttings are the waste products from the drilling operation, which traditionally were discarded overboard. And then very large structures in excess of 10,000 tons. So there's a number of elements of decommissioning. So there's the elements which you just have to do because it's determined by regulation. So you have to plug and make safe the wells, plug and abandon the wells, as I just described. You must remove the topsides and structures which are above the surface, and any residual hydrocarbons and debris as well have to be removed. Where there is some optionality, and that is dependent on agreement with the regulator based on evidence and comparative assessments, is on large jackets, pipelines, what's at the bottom of some of the cells, and drilling cuttings as well. So these are the areas where you have to do some engineering and environmental assessment in order to determine what is the best way to decommission, either to remove it or to leave in place. And this slide shows one of the main dilemmas of an operator on the timing of decommissioning. And it all centers around how best to manage an aging asset. So if you've got an asset out there, you can try and reduce the running cost or the operating expenditure. And if you reduce the running costs, then you can perhaps make the asset run for longer, i.e. you can produce more hydrocarbons, which has a revenue stream. And provide the revenue stream is greater than the costs, then there is an incentive to keep on production. So if you reduce your running costs, you can produce for longer. However, if you run your asset to the ground, or you cut down on maintenance, or you don't do your fabric maintenance or your equipment maintenance, then that means that when you come to remove during the decommissioning phase, you may have to invest or reinvest again. And that expenditure is ABEX, or abandonment expenditure. So you don't want to, excuse me, you don't want to be spending too much effort on reducing OPEX if it impacts your ABEX. And the consequence of these two is finding the optimum time for ending production. And ending production is not a sole choice by the operator in order to stop production, because production is it's an asset for society. Then the government also encourages us to maximize the production of that asset. And what happens is that this triangle is pulled by three separate regulators who do work together, but their focuses can be slightly different. So the Health and Safety Executive is very focused on making sure that we continue to invest in our assets to make sure that they are safe. Treasury is very keen to make sure that our abandonment expenditure is as low as possible because of the tax burden associated with abandonment expenditure. And oil and gas authorities is also interested in making sure that we maximize the oil and gas in the UK sector as well. So that gives you a bit of a background on what decommissioning is about. And I'll now go on to talk about Brent field in particular. And just to highlight that the Brent has been around since the 70s. And this really is the final chapter of what has been a great servant for this country. And what we try and do is to create an environment where we're enhancing that legacy, concentrating on four elements. One is the safety element of it. The next is to ensure that particularly the last platform, which is Charlie, will be the best decommissioned project yet. We want this to be a benchmark for people development as well, which is really important in keeping our staff motivated, and acknowledging that this is an evolving industry. And the last thing is about playing our part in developing lessons learned for that industry. So where is Brent? So Brent is in the north of the North Sea. It's equidistant between Norway and Shetland. So it's a hike from Aberdeen, and those of you in the southeast of England, Aberdeen must sound like near the North Pole. So it is very northerly. It doesn't have much protection from the British Isles with respect to river weather, and it is a pretty inhospitable place, particularly in winter. So the field was found in the 70s, and it was the first major piece of infrastructure in that part of the North Sea. At that time, oil was stored locally and exported in tankers, and the gas was either burnt for fuel, or it was re-injected, or it was flared. There was no capability of using gas. Gas in the 70s was essentially considered to be a waste product. But the vast majority of the gas was re-injected until we installed the flags line, which is the yellow line here going from Brent down to St Fergus. And on the back of that, the gas infrastructure in the UK expanded greatly after that. And over time, the infrastructure around Brent has filled in with a number of other fields in the area as well. So one thing you can say is that Brent is very big. It sits in 140 meters worth of sea, and again 150 kilometers from the coast. It is a very large structure, and Brent Delta, which was the first one that we removed the top size in 2017, you can see the height. It dwarfs the Eiffel Tower as well. And these large structures were made in the early 70s, at the time when there was an energy crisis in the UK, and security of energy supplies was really important for the running of the country. So it was a political imperative to try and be more self-sufficient with the provision of energy. So operators in those days were actively encouraged to move fast in getting these platforms in place. And they did an amazing job. If you look at the time frame from discovery to installation in 5 to 7 years, is probably best in class for equivalent projects even in this day and age. But what is absolutely clear is that when they designed and built these massive structures, no one thought about how we're going to remove them. And that's part of the burden of our current decommissioning project. So Brent consists of 4 major structures, Alpha, Bravo, Charlie, and Delta. They were all being designed and constructed at the same time, although they came on stream a few years apart. And they're all connected by a wealth of subsea infrastructure. Because they were designed in parallel, the designs are similar, but all slightly different. And that gives some challenges, but also some opportunities. So first started production in 1976, and production was maximum in the mid-80s. And in that time, it was producing around 500,000 barrels per day. So that's about a third of what the UK currently produces, and that's just from one field. And we've redeveloped the field a number of times to really maximize the recoverable reserves. So 20 years ago, they changed the whole processing of the field so that it turned predominantly from an oil producer to a gas producer. And what they call they blow down the field, or they reduce the pressure of the field, and that sucks out the remainder of the hydrocarbons. So we've got a very good recovery on the field, and as a result of we have additional taxation on petroleum production. That additional taxation means that Brent alone has delivered £20 billion worth in taxes for the UK government. So you give it to the government, and that's shared around society. So it has been a great aid to the running of the country over the past 40 years. But like all good things, it must come to an end, and that's our current burden on the Brent Decommissioning Project. So where are we at the moment? Well, there's 4 platforms, we started off with Delta. Delta was the first one which reached COP. Then we did the well campaign, moved the topsides in 2017, and dismantling is completed last year, where we recycled and reused 97% by weight of the total topsides. I'll talk about AOR a bit later. That means at oil recovery. Brent Bravo, it's a sister platform. It's the platform which is most similar to Delta, also a 3-legged gravity-based structure. And we downmanned last year, lifted the topsides the same year. And we're pretty close to finishing all of the dismantling at Hartlepool as well. Alpha was our big campaign this year. We downmanned late last year, and then we removed both the upper jacket and the topsides this year in a successful campaign. And the topsides went to England, Hartlepool in England, and the upper jacket went to Norway. The last platform is Brent Charlie. It's the biggest platform. It's still in production. And we've started plug and abandonment there as well. So we're making all of the wells safe. And we're doing that with a novel technique which we changed a bit more than a year ago. So currently we have plugged and abandoned 26 out of the 38 wells. That's currently where we are. With respect to the pipeline infrastructure, we do have the decommissioning program approved. So if you recall, I said that the regulatory framework is to have a decommissioning program which has been widely consulted with stakeholders, and that is approved by the regulator. Once that is approved, that gives you the mandate to execute as per the plan and the commitments in that plan. So we do have the jacket decommissioning plan approved, all of the topsides, so all 4 topsides, and all of the pipelines and subsea infrastructure as well. We are currently in consultation over what we call the field decommissioning program. So that includes the gravity-based structures as well, and that's going through a derogation process. So we're using that ability in OSPAR to request permission to leave certain parts of the assets in place. So that's a summary of what Brent is, and now I'll go into a bit more detail on where we currently are. So we'll start with Brent Delta. So Brent Delta is a little over 23,000 tons, and it was removed by a vessel called the Pioneering Spirit, which is a vessel owned by Allseas. And the evolution of decommissioning offshore has changed over the last 10 to 15 years, with increasingly using larger vessels, so that you can remove big pieces offshore and then take them onshore. And in the southern North Sea, where we have smaller assets, that's relatively easy to do, although they do have specific challenges, water depth being one, for instance. But the principle of doing less work offshore and more onshore is a principle of decommissioning. So Shell, in collaboration with Allseas, developed this ship, which is essentially, in its very simplistic ways, of welding 2 super tankers together, and then between the bows you have some lifting arms, a lifting arrangement, and then you lift the platform from its underside in one go. The clever thing about this is not just the scale, but the ability to lift something very heavy when you are on a liquid world, so when you're floating on something which moves. And that's the very clever piece of technology that Allseas have developed at scale. And the reason why they're able to do that is because they lift quickly. So this topsides on Delta was lifted in 9 seconds using various mechanisms, including rapid deballasting and then swinging arms which swing up very fast using very large scales hydraulic arms. So this was lifted in June of 2017, and then it sails in this vessel all the way to Hartlepool. And significantly, after we lift the topsides, we put caps on the top of the gravity-based structure legs. So there's 3 in the case of Delta. And then on one of the caps, we'll leave an aid to navigation. So essentially an automated solar-powered unit which operates like a lighthouse, a foghorn, and has communication as well with the via satellites. And that's to ward off other users of the sea. So then it's sailed in the Pioneering Spirit offshore to Hartlepool in this case, and then as part of the activities, it's to move the topsides and lower it into a barge, as you can see in this picture. And because of the water depth, or because of the size of the Pioneering Spirit, this has to be done in open sea. It can't. There's no place with water depth so deep in Able. Then we move it onto a barge, and then the barge is floated in and put onto a purpose-built quayside in Hartlepool in Seaton Port. So that was executed successfully in 2017. It took around 18 months to dismantle. In parallel with that, we used the lessons from Brent Delta to say, well, how can we actually improve? And what we found on Delta was there was quite a lot of modifications required on the platform to strengthen the structure such that you could lift using the lift points in the Pioneering Spirit. So we decided to relook at that and propose a number of different things. One of those was a new style of lift points. So instead of having a steel structure which was welded to the platform substructure that would be the interface between the platform and the ship, in the case of Bravo, we poured concrete and from the top sides to create these cuboidic lifting points. And of course, concrete is very good in compression, so it wasn't a problem there. And that resulted in a considerable reduction in underdeck work. And working under deck is always much more inefficient than above deck work. So we managed to install these, the formwork for these concrete blocks, and then pour them in through the top, and that saved a lot of work underneath. And there's a direct correlation with reducing the amount of work offload. Offshore makes it cheaper, and more importantly, it makes it safer as well. So in decommissioning, there's a big effort to try and reduce offshore activity. So in June 2019, Pioneering Spirit came along and successfully lifted Brent Bravo, which was slightly heavier at 25,000 tons. So in 2017, the largest marine lift was Brent Delta, and they came back in 2019 and blew their world record in 25,000 tons. And again, you can see the top right picture of this is what it looks like when just after the lift, and the clearance is in the order of 3.5 meters. You can see around the legs a number of pipes. So these are risers, caissons, and they all have to be pre-cut prior, and everything that's inside the legs has to be pre-cut as well. And that's part of the preparation activities we do prior to removing the top sides. And the picture in the bottom is Brent Bravo again, as it's floated in on this on what's called the Iron Lady barge. So it's a massive barge, and you can probably just see the size here. These are people standing on the new build quay, just to give you an impression of the scale of one of these very large structures. The other thing you might see is that this structure is not shiny and new as well. It has been battered for 45 years in the north of the North Sea, and this is the reason why we have to take it in and dismantle it. So this year's challenge was Brent Alpha, which was a different structure in itself. It's a slightly smaller top size at 14,000 tons, and the upper jacket is in the order of 10,000 tons. So these are very, very large numbers, and I don't mean to sound complacent. It takes a huge amount of engineering and just the lifting apparatus. So the lifting hooks on the crane vessel themselves are 500 tons, just to give an idea. But we split the project involving different members of the supply chain. So we try and do as much as we can from the platform while the platform is still manned. And then we had Allseas lifting the top sides, and then we had Hirama marine contractors lifting the jacket. And couple of the novelties we did on this part of the project was for the jacket, for instance, we have these conductors. So the conductors are essentially the pipes, the vertical pipes which the wells sit inside. So as part of the P&A campaign, we remove the well elements of it, but we're left with this conductor, which is just essentially a barrier between the wells and sea. And ordinarily, you have to remove those piece by piece from the top sides. And when you've got 28 wells in the case of Alpha, that's a lot of lifting. So we managed to devise a plan where we would lift the conductors with the jacket, and that saves a stack of work offshore, which is good for everyone. And just to give you an idea of some of the work that we do, so a lot of the work under deck is done using rope access technicians. So here we can see they're cutting the upper part of the conductor, and so this is a conductor. They're cutting that in sections to bring up, and we only needed to do that for the area above the sea. The conductors below the sea were lifted with the jacket. So here they're installing a high pressure water cutting mechanism off of ropes. This is a cutting machine for a larger pipe, as well, being maneuvered into place with rope access technicians. And this guy here was preparing for the leg cutting campaign as well. So the legs were cut 6 meters above the surface. And then the whole platform was down manned in October, and we had cut two of the legs, two middle legs. There are 6 legs on Alpha. And then we came back in May of this year with a vessel, and from the vessel we cut the legs above the surface using again rope access technicians, but this time the platform was not manned, and we needed to do that because with the legs cut, the platform is not stable enough to withstand the big waves during the winter. And then in June, we lifted the platform with the Pioneering Spirit. You can see the Pioneering Spirit is just moving away from the jacket structure. And then in July, a vessel called the Sleipnir, the largest crane vessel in the world, lifted up the jacket and took it to Norway. So this is a bit of a video. I hope you can see it's not too jumpy. It's just a few seconds of the moment of the lift of the jacket. So you can see all the conductors have been removed here. They normally sit in this area, and you can see some temporary rigging that's been put in place. So the cut level is down near the bottom of your screen, just so you see it. And what we had to do was install these, what they call bearing blocks. So these are welded onto the legs, each of the 6 legs. So 1, 2, 3 on this side, and we've got 3 on the other side. And the pioneering spirit with these loading arms, they sit underneath the bearing blocks. And what the trick is when you lift is because these legs, they actually they move in, they are in different planes. So they're an angle towards you, they're an angle to the left as well. And once we pick up the jacket, or pick up the top sides off the jacket, the legs tend to want to spring out as well. So all of that has to be engineered. So hopefully you can have a look at this. So you can see it's lifted clean out in a few seconds. And you probably think the vessel actually sinks as the weight kicks in slightly, and then the deballasting helps to lift the whole thing up. So I mentioned that we've been using very large vessels to help us move things off of the offshore platforms, but at the end of the day, it all ends up onshore. So here we have top left. Last year we removed the drilling derrick, which was not operating very well. We moved that and took it onshore in the bottom left, and here it's relatively quick to demolish. This is Brent Bravo in the middle, nighttime lift. This was it just after it was being lifted, and then it goes onshore, and then the same with the jacket. The jacket being lifted out the water with the Hirama vessel, and then loaded into the yard in one of the fjords in Norway as well. And then dismantling is a special art as well, and it's counterintuitive to a lot of construction. The principle is that you try and limit working at height. So you send in a minimal number of highly trained crews to weaken the structure, and then you try and bring the structure to the ground. And once it's on the ground, you try and attack it with machines. So that's the principle of dismantling. It's a bit counterintuitive, but it can provide some quite dramatic footage as well. I just want to highlight that what you're seeing here is a highly engineered piece of activity in weakening a structure so it collapses in a certain way. So that was about 1,200 tons dropped to the ground. So the ground, the quayside is concrete, very thick, strengthened concrete quayside. And when there are any spillages, you just mop it up from an impermeable layer, because minimizing spillage to the environment, of course, is absolutely key. And then we move on to Brent Charlie. So Brent Charlie is the big one. It's a little more than 30,000 tons. It's different design again. It's on 4 legs, and it's still producing at the moment. So the best type of decommissioning you can do is to actually start reducing your well stock with P&A at the same time as production. Production is still revenue. And the other element of it is the gas you get from production you can use as fuel for your power system as well. 150 kilometers into the sea, you can't plug it into the nearest power socket. We have invested considerably. So 2016, 2017, we upgraded a number of the facilities and added new power generation to make sure that we do finish the platform decommissioning scopes in a efficient way. And then the other thing is that we have the luxury of learning. So the trend is that every platform we do from Delta through to Charlie will be done safer and it will be done more efficiently. Another key element of the project is moving from the hardware is the residual hydrocarbons which remain in the in the gravity-based structures. So that's 3 of the platforms. So there are a number of concrete cells there who act as storage and separation units as well. Again, the process is slightly different between the platforms, but the principle is the same. You pump everything out and there's always a little bit left on the top. We have embarked on a program of developing technology in order to drill into the top of these cells and essentially suck out the very last remaining elements of hydrocarbons in each of the cells, so that what's remaining in the cells is essentially seawater. And we have had a number of years developing that technology, and in 2014, 2015, 2016, and again in 2018, that was all done off of the platforms to prove the technology. This year we embarked on a focused vessel campaign in Bravo, and we managed to successfully turn a new technology that was proven into an efficient execution campaign. So we did manage to achieve that, to remove all of the trapped hydrocarbons. And how we do that is we transfer all of the residual hydrocarbons into one receiver cell for each of the 3 gravity-based structures, and then towards the end we'll bring in a tanker, and then we'll suck it out the 3 receiver cells into a tanker and take it to shore. So this has provided an enormous technical challenge for us. These storage cells are 60 meters high, and so they're 60 meters off the seabed and 80 meters down from the sea surface, and drilling into 1.5 meter reinforced concrete to ensure that nothing from the marine environment goes inside and nothing from the inside is leached into the marine environment was a big challenge, but we managed to do that on Brent Bravo this year. So as you can see here, there's a very, very small amount left on the top, but even a small amount at scale times lots of storage units, it means that there is a certain volume of hydrocarbons we're obliged to safely remove. And so that's what's inside the gravity-based structure, that's what's on top, but we have an enormous amount of infrastructure below. So this is just a simplified diagram, and if you remember, I showed you at the beginning of the presentation, a lot of infrastructure has been built in and around the Brent field over the last few decades. So we've had to install a few years ago some new pipework, new pipelines to ensure that production from other fields is not impacted when historically it went up and over or past the Brent field. So the whole bypass, it was called a bypass project, was about disconnecting and reconnecting infrastructure so that the production could continue even when Brent was not there anymore. And we then are obligated to ensure that everything that can be removed subsea is also removed as well, and that campaign will start in the next couple of years. So what are the key lessons? What are the key lessons for us? So 40 to 50% of any decommissioning project is the wells. So understanding the reservoir, the condition of the wells, and ensuring that the reservoir is isolated from the environment is really important. And acknowledging that record keeping from when those wells were drilled, the integrity of those wells over time may be changed, and the number of barriers. These are all things that need to be ironed out and decided early on. So you can see that not all wells are vertical. The diagram on the top is actually how the wells look in Brent. And you can see that from Alpha, Bravo, Charlie, Delta, you see that all of these wells go to different parts of the reservoir. So it's very, very complicated where we have wells on top of other wells as well. So making sure your plug and abandonment campaign is efficient and well costed is a big part of decommissioning. The other element is end of field life. So, and that's all about planning prior to COP or before you stop production. And that means plug and lubricate before P&A. So what that means is that you actually go inside the wells to make sure that you know the condition of the wells using a small piece of equipment called a mast. And you do that before plug and abandonment campaign when the big rig is there, and the big rig is more expensive and you want that to work efficiently, so without without surprises. And then a big chunk of decommissioning is actually the operating cost, so the cost of what's sometimes called cold stacking, the operating cost of running the asset even when you're not producing anything, and that can be significant. And many people think, well, as soon as you turn off production, then your maintenance cost goes down. Well, it doesn't really. It goes down certainly 20–25%, but it certainly doesn't half. And the reason for that is, particularly if you're still running on gas-fired power generation, you still have all of your safety systems. You still have all of the people who need to be housed and fed. You still have all your logistics costs as well. So the real step down in maintenance is when you remove all your hydrocarbons, and then you can switch off a lot of your safety equipment that was primarily used for hydrocarbon risk mitigation. And then you run on diesel, and diesel is a lot safer than high pressure gas as well. And then there's certain ways of behaving with respect to how OPEX focus and ABEX focus. So OPEX is looking to minimize the running cost. ABEX is more about how efficiently can we operate the campaign to get everyone off the platform. And that means a slightly different way of working. And in order to keep that efficient, you need to ensure that there's reliable power and craneage. There's a lot of lifting and decommissioning, so maintaining the cranes is very, very important. And then there's a lot of change during decommissioning. Steady state operations is all about keeping things the same and tweaking things in a small incremental way. Decommissioning is about moving through different phases of the program, very much like a construction site. So it is a much more rapidly changing work environment, and then subsequently the risk profile changes as well. Another aspect I mentioned earlier, dismantling is different from construction, and we certainly have learned in Shell UK that we are not the direct experts in dismantling, and we rely a lot on the supply chain to do the dismantling of these very large structures. And that mindset is changing. It is an evolving industry in itself as more and more oil and gas facilities come from offshore to onshore. And whereas quite often in construction we're trying to do things as fast as possible because we want to get to a goal to produce revenue, dismantling is quite different. We can offer quite large windows of opportunity. And there's a lot of mandatory obligations and regulations which have to be considered as well. And then there is a great opportunity of a circular economy, of which we probably have some way to go, and it is a way of how much can we reuse parts of these old platforms as well. One of the last things I want to cover is just about collaborative thinking. So decommissioning is a great opportunity for working in a more collaborative way. At the highest level, operators are not in competition. It's in everyone's interest to decommission these old facilities at lowest cost, be it Treasury or the operators as well. So we can have collaboration at the operator level, but also with the supply chain as well. And it is an evolving industry where technology has moved and the ways of working has moved as we greater understand the challenges associated with removing these large structures. And Brent has shown that if you have a number of these platforms, one after another, you can make some sizable improvements as you go ahead. And that can be done at scale as well. So don't just do decommissioning per asset, but look at bringing them together under our portfolio, and then over time, you will be able to decommission more efficiently. So we used a project collaboration toolkit from ECITV on our Brent Bravo project, and that offered some great reductions for creating creativity in reducing essentially offshore work by reducing the technical scope. And then when we were offshore, we made sure that people were set up so that they could work very productively. And on a like-for-like basis, that created not just 1 or 2%, but it was 70% reduction from Delta to Bravo. We didn't get so much of an increase on Alpha, but again, an increase or an increase in efficiency or a decrease of effort. And some of the things that we did was to be totally transparent in the schedule, and then a real encouragement from everyone involved to promote novel scopes, create and push ideas for doing things slightly differently, and continually focus on what the end game is. So focus on the solution, not the process. So just to finish, so Brent is one of many fields. We've learned a lot on Brent, but it is almost the tip of the iceberg with respect to what's remaining in the North Sea and globally. So it has a big potential for being a source of export of these skills around the world. And that's all I have. So back to you, Rob.
Excellent, thank you, William. Great presentation and great insight. I must admit, it's not something I know a great deal about, so it's great to learn about the process and the size and the weight of some of those some items. Really was impressive. So I've had some questions, if you don't mind. Yep. So the first one's coming from Catherine, who said, stakeholder management is clearly a key requirement for this scope. Do you have any tips for effective stakeholder management?
So stakeholder management is one thing. It's very, very difficult to do perfectly, but it's really easy to do really badly. And the trick is, and decommissioning is a good example of how to do it well, is you've got time to consult with everyone. So decommissioning shouldn't come as a surprise. So it's something that can be well planned. So stakeholder management is all about getting out there and establishing who they are, and take time to listen to what the concerns are. The other thing is being open. So open with what you know, but also be open with what you don't know as well. And don't speak to people or organizations once, speak to them on a regular basis. And it will over time become clear on who's more interested in what you're doing and who's less so. There's an element of being brave about not you don't have all of the answers as well, and I think that's an important part of stakeholder management as well, because very often, and we've found on Brent, is we don't have all of the answers, and quite often you can be influenced by others. So there's an element of the structure stakeholder management that needs to be there as well, but then there's an element of active listening.
Excellent, thank you. Just to let you know, Mark's just posted a comment that just said excellent and informative presentation, so thank you very much. I can also see that there's a theme with 2 questions, so I'll try and combine them. So Lizzie and John are basically, in a roundabout way, said the decommissioning industry is developing and learning from each other's projects. How do you ensure knowledge is retained and best practices are adopted for future campaigns?
Yeah. We get asked this question a lot, and it is really good. So I get that there's a number of levels. So within our organization, so within the Brent project team, so we basically have the same project team running from asset to asset to asset. That's a bit of a luxury position. Then globally, we have what's called a decommissioning and restoration center. I didn't make up that name, but that's what they're called. They're a group of people whose role is to look at all of our global projects, and they keep a lessons learned and also connectivity of people involved at the same time. On an industry level, we have two main groups. It's the Oil and Gas UK. They've got a decommissioning arm with a decommissioning manager, and they do lots of publications, and they organise forums. There's a decommissioning forum we're all tied into. And then there's the supply-led Decommissioning North Sea organisation, and they've got a database. I actually forget what the database is called, but it's in their website, so they have a database as well. And another area we have is the regulator. So once a year, we get hauled into Oil and Gas Authority, and they show us benchmarking within ourselves. And they always ask, how are you doing lessons learned? The other area is maybe not known by everyone, but a lot of these fields are operated by one operator, but they have a number of shareholders. And so we have shareholder forums. So, you know, and if I just use an example, Enquest are an operator of a decommissioning project at the moment, of which Shell is a shareholder. So we contribute ideas to them, and so we share ideas between operators as well. So that's probably the four main areas of lessons learned.
Excellent. Thank you, William. And Lizzie and John, I hope that helps with your question. Ashok has said, love the presentation, extremely informative. Thank you, William. And we're also getting positive comments about the answers you've already given as well. Barry's asked, great presentation, thank you. Is there a specific different project execution life cycle approach to, say, the traditional design, execute and implement model? Don't know if that's...
Yes, so there are and there aren't. Okay, so I'll start that. The highest level is it's still a project. Okay, that you still have to deliver something to a certain standard over a certain time frame, and ultimately for a cost. So a lot of the main building blocks are. Where it's slightly different is a lot of the engineering, you're only engineering for execution. So a lot of so we call it a solutions led. So we actually don't start with the engineering. We say, well, what we're trying to achieve, what can we do to engineer it? So some of those are so we do a bit of engineering to work out what the execution methodology is, and that may lead to more engineering before we execute. So there's tweaks of it, but the principles of planning phase, design phase, execute phase, closeout phase, they're all the same. The risk management, that's all the same. The cost schedule focus, that's all the same. But just some of the tricks about being solutions oriented. So you design to make solutions easier. That's probably the main difference.
Excellent. Thank you, William. So it leaves me with great pleasure to say, William, thank you on behalf of the APM and also the APM East of England branch for giving today's webinar, and also on behalf of the delegates who have joined us today. They're submitting comments saying thank you as well. So thank you for your time.
No worries, it was a great pleasure.
Excellent, thank you. And I'd also like to say thank you to everyone who's joined us today for submitting some great questions. Please keep an eye on the APM website for upcoming webinars. It'll be great to see you at future events. But most importantly, keep well, and we'll see you soon. Bye for now.
Bye-bye.